I'm a firm believer in whenever something can be reused, recycled or reduced, do it. I hate one-use throwing, use and throw away things. I mean, obviously I know sometimes it's a necessity, but where I can, I'll always use reusable or fully recyclable things. So put this little thing together in my attic. I do, if you've looked at my channel, I do small experiments just so that youngsters can see and get on, and enjoy STEM. I think a lot of the stuff, from my personal experience anyway, of what was done in school is quite boring, and science, all sciences, physics, chemistry is my boy, but any of the sciences, they can be quite heady, and especially what you learn in school, it's quite matter of fact, very numbery, very mathematically, which is great. And if you love it, like I love it, it's fine. But I think there's a lot more to science that people don't see, especially chemistry, because it's awesome. And I'm doing little experiments here, like ones you can see. So things like recrystallizations, where you see the crystals form, things like precipitation and solubility, so you can see different colors and things crashing out, which is exciting and vibrant. So yeah, but obviously things are very expensive, the glassware and stuff, because it's precisely engineered, etc, etc. Now, I'm not blaming anyone, people have got to make their money, I understand it, but I thought, right, see what I can do, see what I can build with the minimum amount of having to buy. So I have done little videos of my things, I've done before, but I thought I'd just go through now and just go it all in one. Okay, so that's enough for an introduction. My apologies. Okay, this is my home condenser / reflux setup. So the water doesn't come from a tap. Every reflux or condenser I've used in lab or college or university, I'm sure you'll all see, it is always from the tap, because you need the flow of water, which is understandable. But this system I got here seems to be very, very good. So there's two rates that I get to. I've got a mark on each. So I've got a mark on this, the actual, so you can see I've got a cute little baby G-clamp here, and there's a mark on it where I know what the flows are. So there's two flows I've managed to do. I've done 3 runs to average it out. Got 7 minutes and 15 minutes. So at the slowest flow rate, that gives tidy, but still gives enough flow to be called a flow rate. It gives me 15 minutes, and at the fastest, boom, like if you're doing a more high temperature reflux or condense, you get 15 minutes, which isn't bad for a completely reusable cycle. Now, this is a 2.5 litre container. This is a 2.5 litre container. Now, as the water feeds down through this tube, once obviously the pressure is left off there, it falls through, in through the bottom, up through the top, as all good condensers and refluxes are. The water flows up and down. Now, what's really good about this is, once the water runs out of here, because it's gravity based, first of all, there's no electricity used, and the next good thing is, basically, as it comes through, once this runs out, this becomes locked, because an airlock forms there, because there's no more water pushing up and through. So you can literally, this is flowing now, so that's fine, but you could literally take that off when that's empty and nothing comes out of there. Another good thing I found is because I'm only doing little things at home, just little experiments to, for fun and stuff like that, nothing big or super dangerous or whatever, this flow rate is fine. I find that the 2 litres, which is the fill line there, comes through, and by the time this is filled up, and because obviously there's 2 litres there, and it never overflows, this doesn't. So by the time this water's gone through, because I've strategically actually left this, it's on, but it's not on super tight. So any water vapor that's taken more heat, taken the most heat, can escape through there, and this lowers the overall temperature because it can lose energy to the system a lot quicker. This is the little escape valve I got, because obviously you can't heat a closed system, that'd be silly. So you've got this is where the heating happens. So obviously I've got a bit of foil in there that helps the condensing at the top, falls through, the cooling helps it falls into here. Now, the bit of an issue I noticed at the beginning was smoke coming out of there, because obviously this feeds through, and there's a tube that comes through here, and then the surrounding is where it comes off there. So what happens is then, when if this gets hot, the vapor or whatever comes off can come out there. It's not, because if you accidentally heat the closed system, things can explode, and that's not good. But obviously you don't want that stuff hanging around, even if it's just water vapor, or if you're doing a gas test and you've got, like, you know, carbon dioxide, you just don't want it pumping around. So I've got this little piece of tubing, goes up, screws through here. If I need to take it off, I just undo this little system here, and it just pulls through, and that just lets anything go off and up there. Obviously the rest of this is sealed, so the only place it's going to come out in any, you know, in any case is here, because it will always take the path of not something but a liquid or gas or anything will always take the path of least resistance. So it comes up, comes down, anything heats up, it just shoots out there and goes away, which is great. Onto my next pride and joy. This is my homemade fume hood. Basically, I had this old plastic box lying around that used to have like claws in it and box in it and stuff like that. So I screwed 3.5 inches of wood onto the side to get the height, because I noticed, obviously, I've got a heating plate, but that bar was literally like about 1.5 inches too high when it was just on its original front end. So obviously I had to raise it up, and I raised it a little bit more to give a bit of space. This is the flue of my old boiler, steel flue. It sits in here. And it basically just comes out with a bit of persuasion. You just pop that out, so it's sort of more, basically that can come out and it's more movable. You can move and everything can be sorted, so that's fine. There is a computer fan at the top that acts as the extractor, so when you're ready you just plug it in here and voila, and then you get flow. Now that comes through, and it's I've done tests on it, you know. I've done tests to see, like, I've lit a bit of paper in there, and as the smoke comes off, it is good. It does flow well. So there's a magnet down here that clips into there. There's a magnet down this side that clips into there, and then there's a little bit of wood here with old clothes peg that I remodeled, screwed through the face of the sheet in, and then just drilled a hole through there, pilot hole through. So that just goes into there and done. When you don't want to use it, you just pop that off, unclip the two magnets, and he rolls up onto the top there. Sorry, it's quite hard to do with one hand, my apologies. So yeah, that comes up, and you can do whatever you want, and then you just close it, boom, magnet clips, in he goes, and you've got that lovely seal. Now obviously the fan, I'm going to unplug it now because it's quite loud. The fan is also, you know, but it's a safety aspect. I did try this without the fan on. It works perfectly fine if you've got heavier gases, like the gases, I'm sorry, like smoke for the carbon monoxide or carbon dioxide or whatever, that are lighter than air. They'll go naturally, because if you think about it, for a gas, the path of least resistance, as I just talked about, is it's easier to go up that vent than to fall down, come through. It's just a nightmare. And these curves on the corner help that tuck around, so the easiest way for the gas to go is up. But obviously I'm aware that some gases are heavier than air, and that's why the fan is in there. But yeah, it works fine. I've got this, which is my homemade gas collection system. Basically in there was bicarbonate, and I put vinegar in there, and obviously it turns into the sodium acetate, water and carbon dioxide. The carbon dioxide comes through this, this was the syringes you get in Calpol. One of them comes up, fills the balloon. The balloon's just held on with this little rubber band that goes over, and then it's complete. You just take it off and reuse it. I've got here showed 50, and then I just write what was saved in there, and I got these little balloons. Then when I want to get it out of the balloons, you just basically, where you've tied it off, you just pinch a little bit lower, twist it round, and you can use it as you please. Then this is my homemade manual vacuum filtration flask. So I've got a foot pump here. That's to push air in, that's to suck air out. So the foot pump, basically you just push the foot pump and it's actually got quite a lot of bang for your buck. This tube up here comes down to there, and that's just fixed on there. I've got this that can be added over the top, and so once you're going through, you basically place it over the vac and it dries it out right at the end, and it gives it a good, it lowers, it becomes like a little mini sort of vacuum in there that lowers the temperature of the boiling point temperature, and then you can dry it off easier. So yeah,